Well, howdy there, Internet students. If you didn't do so well on your Objective 1.4a, then you're watching this retake prep video. Make sure you take notes because I want to see those notes to make sure that you watch the video and you're hopefully learning something that you didn't know the first time you took the test so that when you retake it, you can pass. Okay, so this objective is about identifying lines that are parallel and also telling if points are collinear. In other words, if they all line up by using slopes. So let's just review what it looks like on a graph if lines are parallel. So I have a graph here, and let's say I have a point right there on my graph. So let's put a point right there. And then maybe I have another point right let's say maybe I have another point there and another point there, so I'm making a straight line out of these points. Okay, and if I draw a line through those points, so we have that. So let's say I want another line that's parallel to that. Well, if it's parallel, then let's say that I start with this point here. I need to have the same rise over run, so notice these dots are up 1 over 4. So if I go up 1 over 4, I will have another line that's parallel to my first line. Okay, so basically what I'm saying here is we need to have the same slope, 1 over 4, 1 over 4. In your equation, the slope is the coefficient, the number in front of x. So in this first problem, as you look at all these equations, you want to find the one that has the same slope in the equation, the same coefficient. So this one has negative 1/3, that's not the same as 3. This one has 4, that's not the same as 3. This one has a 3, but this is not a linear equation because of the squared there. So we'll eliminate that. So the answer is D. All right, now as you do the rest of this video, you can either pause right now and then do a couple of practice problems till we get to the next problem that I do in the video. Either that or you can just take all the notes now and then go back and finish your practice. So I'm going to do number 2 now, and then there's going to be some more problems like that. But so we want 2 equations that represent parallel lines. Okay, so there's 2 equations in each one. We just need to circle one of these. So we just basically want to make sure the coefficient is the same, not that one. So looking at the coefficient here, not that one. On this one, both coefficients are 7, and they're both linear equations, so we're going to take that one. The last one, again, when you have an x squared, that's not a linear equation. All right. I'm going to move on to problem number 3 here. So we're going to try and figure out if these are collinear, these points. Well, if you have 3 points and they all line up, you're going to find that you have the same rise over run between the first 2 points as you have between the second 2 points. So that's what I'm going to do to figure this out. Now I like to set it up into a table just because then it's easier for me to see what the difference between the number is so I can find the slope. So my first point is 4, negative 12. Then my second point is 6, negative 3. And I'm separating these so I can find the differences in between. So the difference between the y values over here, this is going to be your rise. And the difference between the x values is going to be your run. So I'm going to do negative 3 minus negative 12 to get my rise, and that's equal to 9. So basically what I'm saying is, and maybe you can tell this, that those are going up by 9, and then those are going up by 27. 24 minus negative 3 is 27. Okay, now my run is the difference between 6 and 4, which is 2. 6 minus 4 is 2. 12 minus 6 is 6. So now I need to compare this ratio of rise over run, 9 over 2. Now, to do that, I'm just going to divide 9 over 2. I think that'll be the quickest way. So 9 divided by 2 equals 4.5. So there's a slope of 4.5 there. And then I'm going to do the rise over run from between the other 2 points there. So I'm going to do 27 divided by 6. So 27 divided by 6 is 4.5. Now, since those are both the same, we have the same ratio of rise over run, which means my 2 points, my 3 points are collinear. So we're going to say yes, and my proof is right here that we get the same rise over run between both points. All right. One more problem to go over here. On this one, we're going to try and figure out what value of k makes the points 4, -18, 6, -26, and 12k collinear. You could use slopes to figure that out. What I'm going to do is I'm going to just actually find the equation that represents the line that goes through those 2 points. So I'm going to take my graphing calculator, and I'm just going to enter in these points 4 and 6 for my x's. And I'm going to let my calculator get the equation for me, and then I'm going to use that to find the missing value. I think that'll be the quickest way. So -18 and -26. And then I'm just going to do this linear regression thing that you guys have been doing so much and are getting so good at. So my equation is y equals, get that back quick, my slope is -4 and my y-intercept is -2. So there's my equation. Now I have an x here and k is actually the y value. So I'm going to take that 12 and multiply it by -4 and subtract 2 to get the y. So that's -48 minus 2, which is -50. So the missing value is -50. All right, finish those up, and when you got it done, send your work to me via email, and if it looks good, I'll get that test to your parents. Good luck with that.